So what's up mga ka-che? It's Kuya Dale here. So it's good to be back here in YouTube. So I haven't been posting my videos for a while because I got sick, especially in last week of January, um, and then up to the mid of February. So and also I haven't I'm so caught up with the review so that I have little time to make this YouTube videos. So now, for my next content or for my comeback video, I think I thought of a solving problems from the internet. Um, Basically everything. So especially I got them from ChEG. I think kalabita, those problems na hindi mo makikita ka dahil babayaran mo pa. There's some people posting their questions in the internet, and I think I might have a solution to their problems. I think, and also shout out to the dogs outside who's not so. I hope you will sleep. Okay, so shout out sa mga colleagues ko doon sa Philippine Institute of Chemical Engineers, Young Engineer Section, sina Kuya Joshua Bon Roco, mga engineers na to guys, mga kuya ng tawag. Sina Kuya Paul Acosta, Kuya Mark, Gy Laurente, from ABI, doon ako nag-OJT, my fourth year summer, sina Ate Kaye Magtagñob, and especially Kuya Von of saan nga ba siya nagtatrabaho? Manilad, I think. Manilad. Yung mga engineers na yun, guys. At yung other people from UTLB, I can't mention. I've forgotten their names, but I have one person who's helped me with these problems, and it's Sir Lowen Borja Shar, na apo ni General Delphine Borja. I think, sir, sorry, sir. Joke, that's okay. But thank you. He has helped me um, realize what ano yung mga ginawa kong mistakes sa mga problems na ito. And I thank him for helping me solve this. Okay, so we're now at doing a ChE review series. So ChE board exam review series. So just to help you find problems in the internet, and then you can solve it together. And I hope this can help you, okay? Especially if you're reviewing right now for the May 2021 board exam, or hindi man matuloy sa October 2021, okay? So let's start, shall we? So, now we will be in the ChE calculations muna tayo. This is the first video I will be making for the chemical engineering review series. Okay. So first, the formula of the saturated hydrocarbon and hydrocarbon N2 mixture was determined by burning a sample of the mixture with 30% excess air. The combustion gases were analyzed and showed an ORSAT analysis of 8.95% CO2. Okay, so you read the rest, and 81.61% N2. So what is the formula of the hydrocarbon? So this problem is actually found in Fielder. So this, I remember our exams back when I was third year, so it was really difficult, and I managed to find some. So it was modified. So it was purely in hydrocarbon, but here in this example, we have a nitrogen. We have nitrogen, so we can't really find the amount of O2 supplied by just using the N2 here in the flue gas alone. So we need to make some adjustments to our solution. So how do we solve this? Is that let's draw the system first. So we have a hydrocarbon and N2 mixture, and we were given also the air amount of air, which is 30% in excess. So 30% excess air. And then we have the flue gas. Let's just call it G, CO2, CO, H2, O2, and N2. So let's just list here. 6.46 and 81.61 for the nitrogen. So now, um, uh, as a really check, as you have learned from me this past year. So what are we gonna do? So these are gases, right? So if these are gases, so we have to uh, state our basis. Diba? So basis, if these are gases, so most likely they are in mole basis. So we have to make our basis as 100 mole of our flue gas, or G, so we call it. So to go about this problem, we have to find the amount O2 first. Uh, so to find the saturated uh, formula of the hydrocarbon, so it is saturated, right? So if it is saturated, so it has the formula of this 2n plus 2, saturated, so it has no double bond. So we are finding, we are basing our answer in this formula. Diba? So um, we have to find the number of moles of C and the number of moles of H. So from this, we can find the number of C carbon by doing atomic carbon balance. Okay, so we have to get a C balance. Remember, what goes in must come out. Okay, so whatever goes in here, it came from our fuel, right? Because it's a balance. So NC, let's just call it from the fuel, NC, it's equal to the number of moles, CO2, and NCO. Okay, NCO. So let's just copy that. So the number of moles of CO2 is 8.95 plus 0.99 for the moles of CO. And then we'll find that the number of moles of carbon is 9.94 ohms. Let's see. And then we'll have our O oxygen balance. So see oxygen balance. Okay. So remember that what goes in an O balance, this came from your air. Okay. So you have that N balance there. So O balance there. So the the form of oxygen that goes in the burner is the diatomic, right? So you have to, because we are doing O balance, we have to multiply it by 2. Okay, so 2 N O2 from air. So that's the O2 from air. Let's just denote that by A because it's from air. And then we have the 2 moles of O at, on our CO2. And we have 1 mole of O in our CO. And then we have 2 moles of O2 also here in our free O2. This is actually your free O2. Plus, don't forget when you burn a hydrocarbon sample or hydrocarbon, any hydrocarbon, it's gonna produce water. Okay, really will produce water, H2O. So substituting all our what we have. So we don't have yet the O2 from air, but we have the NCO2. It's just substitute everything that we know plus 0.99 plus 2 times 6.46 plus NH2O. Okay, NH2O, we don't know yet what they are. So let's just simplify these. So if we simplify this, we have 2 NO2A. We have NH2O here plus 31.81. Okay, I think I got that right. Now this is your equation. Let's just name this equation 1. Okay, so equation 1. And then we have our H balance. We have our H balance. So H balance. So we have the NH from our fuel, the H here, and then we will account also the balance here. So we have 2 moles of H2 here, and then also we have 2 moles, uh, 2 moles of H2O, right? So we have NH here and 2 times 1.99 plus 2 NH2O. So we have the second equation, 3.98 times plus 2 NH2O, right? So let's just name the equation 2. And as you can see, we have no relationship between NO2A from air and then your NH and then your H2O. You need at least, we have 3 unknown variables and we only have 2 equations. So we need at least one independent equation to complete this. So the magic equation for this is the TiO2. So TiO2. So you need just to remember this. Just put here our NC because I'm gonna delete the lower part. 94 mole C. Okay. So let me delete this. So for our third equation, we have our TiO2. So this is where I was really mistaken. So I thought that burning only C will be accounted for in calculating TiO2, but you have to also account for burning the H. Diba? So we have our TiO2 equation. So we have just remember this formula, atomic C plus atomic H, you have to divide it by 4. Okay, so this is the formula of our TiO2. So this comes from a Felder, right? You just have to remember this formula, TiO2, atomic C plus atomic H over 4. So we have our TO2, and we also we don't have the TO2, but we have the excess air, right? So we haven't used this for information yet. Diba? So we are told that we are 30% excess. So our NO2 from air is actually 1.3 times the PO2, right? So just input the equations there, the values there. So atomic C, we have the atomic C here, 9.94 plus the NH or atomic H that we don't have yet. So this is the third equation we're going to use. And then let's just distribute that 12.922 plus 0.325 NH. Okay, so that's our third equation. So yeah, so we have to plug this somewhere. Well, you have to plug this somewhere, or you also you can also use your calculator to solve for this. So, but what I did was plug equation 3 to 1. Equation 3 to 1. So here to here, diba? We have 2 times 12.922 plus 0.325 NH 31.81 plus NH2O. Okay, then you will have simplifying all of this, you will have the if you simplify this, you have 0.65 NH minus NH2O is equal to 5.966. So that's equation 4. And then solve simultaneously with equation 2. And then you will have let's just erase this. So solving simultaneously, you will get the NH to be 26.507 moles, and then NH2O to be 11.263 mole. So remember that getting these values, your NC and NH, to put it in the formula, you can actually put it directly. So you have to get the H over C ratio. So H to C ratio. So 26.507 over 9.94 mole. So we have 2.67 here at our the ratio. So this corresponds to 1 mole of C that is in our formula. So you can put that 2.67. Then H, remember 2n plus 2, diba? So Rn actually is 2.67, diba? So if you will input that, you will get 7.34. So we have to have whole numbers, so we can just round it up. Diba? So the final answer will be C3H8. And you see it fits because C3H8 propane is a saturated hydrocarbon. Okay, so that's actually the answer. It's propane. Okay, this problem took too long to explain, but I'm really happy. So, and this also, the next problem, I found this in ChED, I can use a ChED, guys. It's just lying around there waiting to be solved. And I hope you can also get this. Um, you can solve it with me. I think it's good. Ba? You can pause the video muna if you want to start answering by yourself. Okay. So, ethanol is produced by the hydration of ethylene according to the reaction. Ethylene plus water yields ethanol. So, however, some of the products are converted according to the following side reaction. So, I think this is ether, diethyl ether. So, the um, the ethanol transforms to this, and then we have our effluent analysis. So the feed to the reactor contains ethylene. So this ethylene, steam is water, diba? Water, it's just a vapor form of water, and then your nitrogen gas. So the effluent analysis is given as follows. So here are the um, mole mole basis. So all are given in mole basis. So we have three actually. So we have many problems to solve. Okay. So we are asked for the fractional conversion of ethylene. Fractional conversion of ethylene is just XA is equal to um, the A in the beginning, and then the final number of moles, and then just divide it by the initial number of moles. So that's the fractional conversion. Yield is actually how much you have produced. Okay, how much you have produced relative to what you have begun with. So yield is what you have produced. Yeah, if you can remember, the it's just the number of moles of ethanol. So in ethanol, 5OH over the moles of the original reactant in C2H4. So that's the fractional yield of ethanol. And then what maximum fractional conversion of the excess reactant. So just have to get the fractional conversion of the excess reactant. So that's XB. So excess reactant here is we don't know yet. So let A be the limiting reactant and B will be the excess reactant. So the number of moles of our limiting reactant over the number of moles of uh, um, our excess reactant, and then you just multiply it by 100. Okay, so that's how you get these problems. Okay, so have um, we have our system here. Let's draw it first. So for easier calculations, I will be writing the um, I will be writing the uh, I will be assigning letters. Okay, so I will be assigning letters. So let ethylene be A, and then B, and then we have C. So just remember that. So we have C here, uh, decomposing. So 2C decomposing to um, D and B. Okay. So this is the main reaction and the side reaction. So let's draw the system. So we have our C2H4 here, our H2O, and then our N2. So we have assigned letters to this. So this is A, this is B, and because nitrogen does not uh, participate in the reaction, we have I for inert. Inert. So that's it. So we have C2H4 in the effluent. We have our water, and we have our ethanol, and then we have our um, 2 ethylene, ether. We have our ether, and then we have our nitrogen. So let's just rename these. So this is A, this is B, this is C, this is D, and this is I. So we have our molar composition for that, which is 39.12%. And then we have 45.08%, 2.95%. We have our 0.27%, and then we have 12.58%. Okay, so let's do what we have done in the previous problem. So um, it's going to be tedious, but it will really give us the right answer. So shout out kay Sir Lowen. So sinabi niyo to, hindi ka imamali nito. So atomic balance. So we'll do atomic balance. Atomic balances. So let's just first get the atomic balances of our uh, elements. So we have our C balance. So we did this in the last problem. C balance. So we have 2, diba? And NA na lang ako na because of the 2 here, diba? But we have 2 carbon atoms here. So 2 Na, and then we have our um, we also have a 2 here in our effluent. So uh, Na, so this is an effluent case. So let me differentiate O and then A, and then we have our 2 NC. There's 2 carbons in the ethanol, and then we have also 4 uh, moles of carbon in our diethyl ether. So we have ND. And then we have our NaO. Now we don't know that yet. So 2 times 39.12 plus 2 times 2.95 plus 4 times 0.27. I don't for these problems, really my basis is 100 moles of gas for the effluent. Okay, so I forgot to state that. I'm sorry. So we have our original moles of the C. So uh, get this using a calculator. So we have 42.61 moles of C. And then we also have to get the H balance. So H balance. H balance. So we have 4 of our Na. So because of 4 here, and then we have 2 of our NH. So B, O, O. And then equals anong lumabas dito sa kabilang side. So we have 4 Na plus 2 of our NH2O and B plus ano pa? 6 of our C and C plus 10. 10 here, 10 and D. Okay, so just substitute all that we have because we already got this. Um, 4 times 42.61 plus 2 NBO, 4 times Na, 39.12 plus 2 times 45.08, and then 6 plus times 2.95, and then plus 10 times 0.27. So if you will get NBO, uh, you get 48.3 moles of H2O. We have CpH4. CpH4 we actually have. So we now have what we need to solve for our system, diba? So let me just put it here in the above. So NBO is 48.3 mole H2O, and then NaO is equal to 42.61 mole C2H4. Okay, so just let me delete. So fractional conversion of ethylene. So we just have to find the XA. So this is for A. So XA. We have AO is A over AO. Diba? So we have 42.61 minus what was left. We have 39.12. Diba? And then 42.61. So we have a uh, fractional conversion. Fractional conversion of ethylene to 0.08. We have letter B, our yield, fractional yield of ethanol. So yield of our ethanol, so it's YC, YC. So you just divide the number of uh, moles here of ethanol over our limiting reactant, which is clearly our our um, ethylene, because it's present in pure number, diba? And remember, it's also 1:1, so clearly NaO or our ethylene is the limiting reactant, diba? So 42.61. So we'll have 0.07 na fractional yield of ethanol. Sabi gamayar tayo, no? And then letter C, we have the percent excess conversion of our maximum fractional conversion of the excess reactant. So let's assume that all of our limiting reactant reacted. Yeah? So all of it reacted, 42.61, and then over our limiting reactant times 100. So we will get 88%. Okay, so it's that how you can solve this type of problem. Okay, so next we have the final problem that I will be doing for this part. So this is methanol. So I think the next part will be the ChE11, if I can remember, in our school, Xavier University. So now it was condensed to ChE15, I think, in the new curriculum. So we will be doing this next time in the next video, okay? The combustion or the industrial stoichiometry. Okay, but for now, let's just solve the final problem. I will be giving to you the methanol. So this is also found in ChE. So check na natin. You can find this in ChE, actually. Um, methanol is synthesized in a catalytic reactor using CO and H2. So CO plus H2 Methanol daw. Methanol. Ano ang uh, um, methanol is actually C3, yeah, methanol. So we also have this actually C3. Okay, so balance. Okay, balance na ba? Okay, balance na. However, a side reaction is observed to occur, which leads to the formation of formaldehyde. So formaldehyde. So formaldehyde, and then fresh feed is the process contains 30 mole percent CO, 60 mole percent H2, and 10 mole percent N2. Okay, so the combined feed to the stream to the reactor containing 22 mole N2 consists of 4 mole recycled per 4 mole of fresh feed. So in the reactor, 9 moles of methanol is produced per mole of, I don't think I can read this. I don't think. Formaldehyde. Formaldehyde. The reactor effluent gas goes to the condenser where two streams merge. So a gas stream containing LCO and H2 and N2, and the liquid stream of methanol and formaldehyde. So the gas stream is split into two fractions. One stream is purged and the other is combined with the fresh feed to the reactor. So letter A, so you're asked for the fraction of CO in the purge system, and then single pass conversion with respect to CO, and then overall pass conversion with respect to C. This is actually CO, yan, CO, CO. That's CO actually. So fraction of the in the purge stream. So I haven't taught you this, but we have the purge. So if we have recycle, we have purge so that all of the inerts will not accumulate and in the mixed feed. Yeah, mixed feed. So you have to purge some of it, and then we also have bypass. So because but we don't have bypass in this problem, where bypass is where fresh feed will not go through some processes and then it will go straight to a downstream process. But just like enriching a flavor of a fruit juice, you will maybe you have encountered that fruit juice problem in your undergrad. So we have our system here. So let me draw this system so that it will be easy to understand. So we have um, we asked to understand this. So there is a reactor, diba? So let's just name that reactor R. But we have streams here. So in the stream, let's just draw. This is the sign again. Symbol for mixer. And then we have our fresh feed. And then we have our mixed feed, so M. And then we have the condenser here. And then we have a liquid product. Let's just call that L. And then we have a here actually a gaseous product. Diba? We have a gaseous product. I don't know. I wrote it wrong. We have a gaseous product there. Uh, the L consists of the methanol and the formaldehyde, and then will be recycled here. Well, let's call this stream R, and let's call this stream the purge or the P. So yeah, purge. We were told that we have a 30% mole composition of CO, and then 60 mole percent H2, and then we have 10 mole percent of N2. And in the mixed feed, we have um, 22 mole percent N2. So we don't know yet the composition of our CO in the mixed feed. So let's just call that XCO. And then as you can see, this this proportion that 1 mole of CO reacts with 2 mole of H2 remains all throughout in the react in the process. So we can safely assume that 2x H2 is equal to 2x, ba? And then we have 22% here, N2. Yeah, and in the outlet of the reactor, we have a um, we have some uh, products, okay, and also unreacted mga reactants. Okay, so we have our, let's just call that N1. We have CO because N2, and then we have N3 because we are more working in moles, so C3OH. And then we have our N4, uh, H2CO, so that's our methanol, and then N5, which is our N2. So in the liquid product, we have our H2CO here and our methanol. So in our purge system, which is you must remember this, the purge and recycle system and the gas, so kinesia, and kinesia, they all have the same composition. Okay, so really remember that. And we also have a special relationship. We have a 4 mole recycled per 4 mole of fresh feed. Diba? So let's just put the 4 mole of recycle per 1 mole of feed. So we have we name it our y as our fraction of um, nitrogen, and then z of our CO, and then 2z H2. So what did I tell you? The 1:2 relationship with CO with H2 remains all throughout the process. Okay, so how do we solve this? Let's begin. So we have to have a basis first, diba? I taught you this, a basis first. So we have to have a basis. So what good tsada nga basis would be? So katong kumpleto o composition, which is our feed, diba? Kumpleto man siya og composition. So we have to we can make an assumption. So 1 mole of fresh feed, diba? So if we have 1 mole or 100 mole of fresh feed, we have a 400 moles of recycle, diba? So kaniman yung din 100 times 4 pila 100. So meaning our mixed feed, kini mixed feed na to 100 plus 400, we have 500 mole, diba? So kana ko lang kabalo na ta sa unsay nakuan answer, diba? So at mixing point, kini kaning x diri at mixing point, you can already have your N2 balance, di ba? N2 balance. N2 balance. So N2 balance, we have 10 moles of N2 coming from here, from this side, di ba? Plus pila ka moles diri, wata ka balo? Just 400 times y, di ba? 400 times y. Yeah, and then for your mixed feed, we have 500 times 0.22. And now we can have the fraction of nitrogen in the purge stream should be 0.25. So 0.25 nasa purge stream. So takabalo, so that's the N2 balance. So we can also have a purge purge and recycle cycle, and actually sa gas kinesia we can have a balance of that. So we now know the Y, which is 0.25 plus Z plus 2Z, and then because all of this will be equal to 1. Because 1 na siya. Okay, composition mo na siya. So it must be equal to 1. So solve for Z, we will have the 0.25. That is incidentally the fraction of CO in the purge stream. So we got letter A already, di ba? So 0.25 is siya. 0.25. Okay? 0.25. And then we have to get also at mixing point. So we were not done with this yet. So at mixing point, so just do this again. So x plus 2x plus 0.22 is equal to 1. So your x, which corresponds to your CO, is 0.26. And then your 2x, just multiply it by 2, you have 0.52. Okay? So I think you're going to be needing that in the succeeding calculations. Okay? So I want you to remember this. Just go back if you want, because I'm gonna delete this. Okay, I'm going to delete this because we need more space to solve our problem. Okay, so just erase that. So at to solve for the uh, so that we will know the composition of the amount of liquid and gas produced. So we will have to um, get a balance in the purge section. Purge section. We have to have a overall material balance there. And then for us to make it easier, we will have to use uh, tie substance N2, because the nitrogen will not react, diba? So it does not react. So we have to find our N2 balance at the purge, diba? So at the purge, so you have a stream there. So N2 balance. So um, at the purge, you have a overall N2 balance. So uh, how many moles of uh, nitrogen went in? So di ba 10 in the fresh feed, di ba 10 kanina, 10. And then we have at the composition of the purge, di ba na ay 0.25 dito na katong Y ganina ato na solve, and then T. So that's the of number of moles sa purge. So T divide lang, have 40 moles. So what does that mean? So at the overall material balance pa rin, di ba? Ganina, ang makita lang ni mo nga mosulod is the F, and then ang gawas lang, ang lumawas lang ng mga streams are yung purge mo at saka yung liquid, di ba? So we have 100 of this and we have 40 of this. So L must be 60 moles of liquid product. So we have 60 moles here. We don't know because it's a mixture. So you have a methanol here, and you have your methanol or formaldehyde. Methanol and methanol. Yeah. So we have a special ratio there. In the reactor, 9 moles of CH3OH is produced per mole of methanol. So we have a selectivity here of 9 moles of methanol is produced per mole of methanol, methanol or formaldehyde. So use that ratio using the ratio 1:9 methanol to methanol. Methanol. So N3 actually your CH3OH, diba? So uh, has a fraction of 9/10, diba? We have 54 mole C3OH. Then we also have a N4, which is the most of your methanol, diba? 60, 1/10, 6 moles of methanol, H2CO. And we now have to find the number of gases. So, katong yung G na ni-produce sa ubos, di ba? So, we have to find, we have to have a material balance around the condenser. So, itong C, condenser, you can remember your the diagram. So, we have the overall material balance. So, na ay isulod nga mixed feed nga M. And then, we have a product na G. And then, we have L and gawas, diba? So, at around condenser. So, we have 500 of this. And then, we also have a um, G. We don't know that yet. And then, uh, we have a 60 moles of liquid product, diba? So, Rg is equal to 440 moles uh, uh, product, diba? And then, we still, just remember this, if you have copied this, diba? Let me erase all in on the slide. So, using uh, pi substance M2. So, at the, kuha na siya guys, at the mixing point, di ba? If you can remember, uh, this is C, R, L, M, F, we have the G, we have P, and then we have R. So, here, in your mixed feed, diba? Mugawas dito kay Otakabalo. But we have 22% of N2 here. So, ang mugawas diri na N2 is also 22% of the mixed feed, diba? So, you can remember the nomenclature I have given earlier. So, N5 for N2. So, 500 times 0.22. So the same amount of mixed feed, the same amount of N2 goes out also the same amount here. Diba? So it because it does not react moles. So we have our CO plus H2 remaining uh, CO plus H2. Diba? We don't know what the uh, how many CO yet and how many H2 yet, but we have the total number of them. So we have 440, the 440 milligrams 3 minus 110 moles. So we have 330 moles of CO and H2. So uh, we have to find the number of CO and H2, but we have the proportion, di ba? Natin proportion, 1:2 na COH2 na relationship. So in CO here, now we have 1/3 sa dito sa itong ratio, 330, and then we have 110 moles of CO, and then our H2, 2 moles of that we have 220 moles of H2. Okay, so we also know at the purge, so in the purge stream, we also have uh, 10 moles of N2 there, right? So it's just a 40 times 0.25. We've done this earlier, the 10 moles. So the combined number of uh, um, CO and H2 there is also 40 minus 10. Diba? So we have 30 moles. We have to find the NCO in the purge, which is using this also relationship. Diba? 1/3, 30. We have 10 moles of CO, and then NH2, 30. We find 20 moles of H2. Okay, so at mixed feed, so we are calculating for the single pass conversion, right? So the single pass conversion and the overall pass conversion. But why we are getting all of this, because this corresponds to the single pass conversion, and this corresponds to the overall conversion. Diba? So at the single pass conversion, we have to find the number of moles of NC. We have to find the number of moles of CO there, diba? So I told you that computation of X earlier of 0.26 kung diri bitaw, kung X is equal to 26%, 0.26 there, it's gonna come handy. So at mix speed for the M, we have the number of CO there to be 500 times 0.26, you have 130 moles of CO there. Okay, so remember these values so that we can solve the overall pass conversion and single pass conversion. So single pass conversion corresponds to this, di ba? How many moles of uh, our reactant CO, because CO, with respect to CO man daw, went in, and then how many went out, and then katong XA kung gitawin na sa previous calculation, and then overall pass conversion is how many with respect to the entire process itself. So di ba? In the purge stream, so muna siya ang ligawas lang ng mga CO. Ini. So we'll use these values, okay, to calculate for the overall and single pass conversion. So let me erase. So letter A, we have 0.25 naman, di ba? 0.25. And then at B, so we have our single pass conversion, XA or SP con single pass conversion, which is 130 man to, diba? Ang kuan mixed feed na CO at before isunod siya sa reactor, then igawas din siya 110 moles na lang, and then divide it by the original, and then we'll have 0.154 nga single pass conversion, and then lastly your overall conversion is atong sa purge, di ba? How many at the beginning, how many moles of CO entered, di ba? 30 lang. And then pila ni gawas? How many went out? 10 over 30 time. So the answer is 0.67. That's the overall conversion. Okay, so that's it for this part. So I'm actually planning to record the multiple parts of this video because it can't be uh, contained in one video. So I'm planning to siguro 3 parts, I think. One for the industrial stoichiometry na part, 2 parts siguro for atong atong combustion na alone, and then we have also for uh, burning of pyrites. So we have pyrites also here. So you won't be disappointed in this video. Okay, so this video is really too long already. So I leave you guys be. So I hope that these problems have helped you in the review. And also the freshmen that are watching this video, I hope that you will learn also from this. Okay? So, naapay industrial stoichiometry simulan. Okay? So, goodbye. I hope you find a good night's rest. Siguro, maybe tanaw, and then I will reserve some of the shout outs siguro akong left out in the other videos. Okay? Good night.